First lesson on rational expressions. I'm Miss Carla, and I will be taking you through this unit for all of your tutorials. When we're looking at rational expressions and equations, it's good to keep in mind that these are used in many different fields: medicine, lighting, economics, space travel, engineering, even acoustics when we're looking at band. I know a lot of you listen to music online. A lot of you look at TikToks. The lighting, the music behind them, it's all included in rational expressions. When we're looking at rational expressions, we have to go back to some of our early definitions. What does rational mean? And from the first week of school when we did a review, a rational number, as we know, it is a number that can be made by dividing two integers. So an example might be 9, -1/3, and 1/2. These are all examples of rational numbers. Miss Carla, why is 9 a rational number? Well, it's actually divided by 1. And 1 is an integer, so is 9. So this as well is a rational number. So when it comes to rational expressions, well, the definition has to follow along the same lines. So it's an expression that can be made by dividing polynomials. Polynomials are made up of integers. So let's look at some examples. What do you mean by polynomials, Miss Carla? Well, x squared minus 4 is a polynomial. Well, how is that a rational expression? Well, just like the 9 for the rational numbers, it's divided by 1. So it's a rational expression. Some other examples: 1 over x, or m divided by m plus 1. Or a little more complex, y squared minus 1 divided by y squared plus 2y plus 1. These are all rational expressions. Sometimes you'll hear me use rational expression or algebraic fraction. An algebraic fraction simply is the quotient of two algebraic expressions. So if we look at the examples from rational expressions, y squared minus 1, that's an algebraic expression, and y squared plus 2y plus 1 is a second algebraic expression. Why? Because we can solve each of them for y. Some other examples would be minus 4 over x minus 2, or t divided by 5, or 0. That also is an example. Two more examples: y squared over 3x to the 5, or even square root of 3x plus 1 divided by x squared. These are all algebraic fractions. It is good to note that all rational expressions are algebraic fractions, but not all algebraic fractions are rational expressions. So it is good to keep that in mind. So always remember, a rational expression is made by dividing two polynomials. Now, if we look at some examples of rational expressions, what would happen in each of the following examples? When our variable x equals 3. Pause the video now, go through each of the 3 examples by substituting x equals 3 in for your variable, and come back for the answers. Welcome back. As we see from the first one, if we put 3 in for x, we get minus 4 on the top and 0 on the bottom. There's a 0 on the denominator. Okay, let's keep that in mind. Let's look at the second one. We have 3 minus 7 again on the numerator. We have 3 squared minus 9 in the denominator. Okay, we got negative 4 divided by 0. Okay. Let's look at the third example. 3 minus 7 on the numerator. Okay, then I have 3 squared minus 4 times 3 plus 3 on the denominator. So I have minus 4 divided by 9 minus 12 plus 3, which is equal to minus 4 over 0. Each of them gives me a denominator of 0. Well, what do I know about having a denominator of 0? Well, I know that in the first one, any denominator of 0, it makes my fraction undefined. The second one as well, undefined. And my third one, again, undefined. So what does that mean with regards to irrational expressions? Well, it means that we have what's called non-permissible values. In words, a non-permissible value is any value that makes an expression undefined. Or, we can say it another way, it's a value that results in a denominator equal to 0. So let's look at A, B, and C for examples. What do you think would make the denominators of each undefined or equal to 0? How would we solve this? Pause the video, take a few minutes, think about it, come up with some answers, and then we'll work on it together. Welcome back. Well, let's isolate out the 2x from the denominator of A. So we're going to set it to 0. Well, if I solve for x equals 0 divided by 2. That means that x equals 0. Well, okay. So if x equals to 0, it's going to make my denominator equal 0. That makes the whole expression undefined. So that means in A, x cannot equal 0 ever. Let's look at B. We have x minus 7. Let's set it to 0. Isolate out my x. X equals positive 7. If x equals 7, again, my denominator will be undefined. So in B, x cannot equal 7. Let's look at C. C is a little bit different in the fact that we have 2 different factors. So let's isolate each factor individually. So the first one, x minus 3. We'll set that one to 0. And when we isolate out x equals positive 3. So in the first one, x cannot equal 3. Let's isolate out the second factor. It's 2x plus 1 equals to 0. Let's solve for x. 2x equals negative 1, x equals negative 1/2. So in the second factor, x cannot equal negative 1/2. So in C, x cannot equal 3, and it also cannot equal negative 1/2. Those are the non-permissible values for C. Let's look at a couple other algebraic fractions and see if we can find the non-permissible values for them. Work on A, B, and C on your own. Pause the video, come back, and I'll go through them individually. Welcome back. In A, we actually have two factors. We have 4, we have the s, and we have the r squared. So I'm going to keep the 4 with the s to make it easier for myself. I'm going to set 4s equal to 0. S equals 0 divided by 4. S equals 0. R squared equals 0. Well, just like our radicals, and I have a square, I'm going to have to take the square root of both sides. So I have square root of r squared and the square root of 0. So that means r equals 0. So s cannot equal 0 and r cannot equal 0 in A. Let's have a look at B. Again, we have two factors. I have x equals 0. I'll isolate that as the first one. And I also have 2x minus 3 equal to 0. Let's work on x equals 0. Well, that's self-explanatory. X cannot equal 0. Now let's look at 2x minus 3 equals 0. We need to isolate out x, so 2x equals positive 3, because we're moving the 3 to the right side of the equal sign. And I can take x equals 3 divided by 2. So on this second factor, x cannot equal 3/2. So x in B cannot equal 0. It also cannot equal 3/2. Now for C, we have a quadratic on the denominator. So we need to pull out the whole quadratic, which is p squared minus p minus 12, set that equal to 0. Now, as part of our quadratic unit, we learn to factor. So let's factor this out. I have p and I have p. I'm going to set the whole expression equal to 0. What times what equals negative 12, but adds together to make minus 1? Well, I have minus 4 plus 3. So now I have my two factors. I have p minus 4 and I have p plus 3. I'm going to set each of those equal to 0. For p minus 4 equals 0, let's isolate out the p. Bring the 4 minus 4 over to the right side of the equal sign. P equals 4. For p plus 3 equals 0, again we're going to move the plus 3 over to the right side of the equal sign. So p equals negative 3. So in C, p cannot equal positive 4 or negative 3. Your turn. Pause the video, try A, B, and C on your own, and find the non-permissible values in each of them. Come back and we'll do it all together. Welcome back. Let's have a look at A. For A, we have two factors on the bottom. We have B and we have C. So let's isolate out 3b equals to 0 and then c equals to 0. So b equals 0 divided by 3, b equals 0. And c is self-explanatory. We have c equals to 0. So for A, b cannot equal 0, c cannot equal 0. Let's look at B, where we have x minus 1 over x plus 2 multiplied by x minus 3. So we already have factored form in the denominator, so I'm going to isolate each of them out. I have x plus 2 equals 0, and I also have x minus 3 equals to 0. So let's look at x plus 2 equals 0 first. So let's solve for x. So bringing my 2 over, I have x equals negative 2. So x cannot equal negative 2. Let's look at the second factor, x minus 3 equals 0. Isolate my x by bringing negative 3 to the right side of the equal sign. I have x equals positive 3, so x cannot equal 3. So these are the two non-permissible values for B. So x cannot equal negative 2, x cannot equal 3. For C, in C, we have another quadratic in the denominator, and it's also a perfect square. So I need to factor out my perfect square. So y squared minus 4, I'm going to set this expression, the algebraic expression, equal to 0. So I can factor this and find my two factors and then isolate out my y. So I have y minus 4, y plus 4 equal 0. And now I can isolate out my two factors, solve for y, and find my non-permissible values. So let's take y minus 4 as the first one, equal to 0, and then y plus 4 as the second one. So solving for y and y minus 4 equals 0, I have y equals positive 4, bringing my negative over. That's one value, so y cannot equal positive 4. And let's look at the second one, y plus 4 equals 0. Again, moving my positive 4 over to the right side of the equal sign, I have y equals negative 4. So y cannot equal positive 4, and y cannot equal negative 4. And this is a way to write it when you have the same number that your variable cannot equal.